Cool. So in order to set up HPC, let me do one last optimization. Sorry about that. Uh, okay. Actually, let me just start through the steps and I will optimize later. That's fine. Cool. The overarching objective of running a job, right? I said the word job earlier, but now I'm going to give some more significance to that term. A job is kind of a assortment of a couple of things. It includes information about the code that you are looking to run, as well as information uh, that the cluster can use in order to determine the constraints within which that job will run. So we have the actual code, obviously your training code or inference code, whatever that might be. And we have constraints like the war time, so the maximum runtime of the job, the resources, so how many GPUs you want. Specifically, you sometimes have to specify what GPU it is if the cluster has more than just a GPU as an accelerator. But for our case with RCAC, we just have the one A100 type of GPU, so we don't need to worry too much about it. The account is the queue under which the job will run. In our case, is MLP-N, and the node type is the node under which it should run. In our case, this is we are operating under the N node. I will make those things a little bit clearer when we run through the code. Besides that, we have more information. If you check out the manual, it will tell you a lot more about the type of constraints that you can utilize. So once we specify whatever requirements that satisfies Slurm, we get the job added to a certain queue. Now this Slurm, it computes our niceness level, or basically not niceness level, but it computes a score for us to tell us how fair we are being in terms of the utilization of our resources. So for instance, if we are being very dominant with the type of resources that we are using, then it will put us towards the back of the queue and prioritize people who do not use the system as much. So it is kind of a notion of fairness where it says that the resources within this cluster need to be divided equally for everyone within this specific queue. So if you kind of spam it, it will decrease the priority at which your job is run. So it does not necessarily always run immediately, but since we have like a significant access of GPUs, I don't think we will struggle with that at all, so to speak. Cool. So next step is logging into clusters. To start off, you can log into the cluster by specifying your username. This is your Purdue alias. And then at gilbreth.rcap.purdue.edu, you can log in with your career account password, and once you do that, it should send you a notification via Duo. And once you enter yes to that, you should have a shell. You should be able to run ls on that, and that should basically signify that something is happening. You are logged in. If you run ls-la, that should actually show something a bit more significant, because just by default, I think there is nothing. No visible directory exists within your cluster. So I am going to demonstrate that. So if I do this exact same thing, let me know if the size is okay. So gilbreth.rcec.purdue.edu. Now in this case, it requests my passphrase. It does not request my Duo authentication. I will get to that in a second. But once I supply that, it logs me in. And if I run ls-la, it shows me the environment. One tip that may or may not be relevant for you is running with the environment variable of term equals xterm. So if you're using Vim and the shell in certain cases, if you are not already using something like tmux, you may run into a situation where the entire thing just completely breaks itself. And in that case, just setting the term environment variable to xterm generally tends to help with that. It also allows for some amount of syntax highlighting. So if I do ls-la, you can see this time the directories are marked in blue instead of just being the plain black white. So once you all have successfully logged in, please let me know, or like successfully entered your system, please let me know and highlight that with green, and I'll move on. If there are any problems, raise your hand. Let me know. Be as loud as possible. Yes.
So whenever I log in, it's pushing to Duo, and then I hit authenticate, and it's just saying that the authorization check failed.
I think that means that you don't have access to Gilbreth. Did you get an email from me? Not from me, but from the Purdue system saying that. Uh,
I joined my team.
You join your team late. Okay, that's not an issue. So if you go through the HPC workshop in the repo, if you go to the Discord server.
Yeah, I'm not in the Discord server because I joined late.
Oh, okay.
Do you have access to add people to it?
Yes, I do.
Do you mind adding?
Sure. Give me 1 second.
Okay, that's fine.
In the meantime, yeah, this is all.
I'm logged in.
Okay, cool. I can set up the thing later on offline for you. If that's cool.
I'll come to you after the workshop.
Thank you so much. Okay, cool. Alright. Rest once everyone is logged in, just give me the thumbs up and I will move forward. 87D128 210 10781.ngrok-free.app. Alright, this is correct. Very cool. Okay, are we running into issues? Do we have Okay. All right. Let me move forward. All right. Cool. Uh, all right, folks. So uh, from there, the next thing that we look at is a couple of very simple tips that I have. So we won't, dwell too much on this. But if you go to your SSH, your .ssh directory, that is where you will mainly delegate access. So over here, I have the config tip out, but probably the more important one is going to be for access delegation. So if from your home directory you type .ssh and you ls, you should see a file for authorized keys. If you do not see it, you can create this file, and within this file, you should be able to enter a list of public keys, and these are in like new line separated, and what that does is it allows you to have someone else log into your account, or even yourself log into your account using a private SSH key that relates to the public key. So if you do not want to use Duo every time you log in, one simple way is to create a SSH key pair, and there is a very nice tutorial for that over here in this GitHub docs blog page that goes through the process of creating the SSH key pair. Once you create it, you should have a file, a pub file, and a file without an extension. The file without your extension is your private key. Do not share it with anyone. But your public key is what you will basically share and add to the authorized keys list, so that when you log in, instead of asking for your Duo authentication, it is going to just use your SSH key in order to authenticate you, and you can enter the cluster that way. So that simplifies that process quite significantly. Okay. Besides that, there one very very important thing that you want to keep in mind with regards to Gilbreth specifically is that the home directory has a limit of 25 gigabytes. What that means is if you try to download a data set that is more than 25 gigabytes, you're going to run into an error that says quota exceeded, and you will not be able to really do anything with that cluster. That is obviously a very very significant problem, and the solution to that is to direct everything that is data heavy to your scratch directory. So we have your sort of setup where I have my home directory, and I have this home directory over here, and I have a couple of files. But very crucially, if I have something like conda that is very significant in size, or a cache directory that is very significant in size, it is going to basically inhibit my ability to actually use the storage that I do have. Now, the difference between your home directory and your scratch directory is the fact that you really do not know, is the fact that the data within the scratch directory can effectively be deleted at any point in time, right? So the data security does not exist. But what that means is you need to have data within that directory that is effectively expendable, wherein if it is deleted, you can run a single command and everything gets reinstated by itself, or in certain cases, you just don't even realize it. It may be your code may run a little bit slower, but overall there is no significant difference. So let us talk about how we can set that up. So if you go to cd /scratch /Gilbreth and / your username, so in my case it's Setpal, and hit enter, you will enter this scratch directory. So in your case, if you have not used the cluster before, it will most likely be empty. Do not worry too much about it, but the main idea behind getting it set up is quite straightforward. All you really have to do is add this line to your bash rc. We are exporting xdg cache home to scratch Gilbreth and then your username. If you like, you can create a .cache directory under this and then export it to that as well. It will not really make a very very significant difference. It's just the semantics of how it looks. But what this does in the bigger picture is just make sure that your home directory space, the storage of which is protected, is not filled with unnecessary bloat. Please remember to replace username with your alias. So let me go ahead and just show you what that should look like. So if you go to back to your home directory, hit cd and enter. This should take you back to your home directory. Now, if you open bash rc, in your case, maybe bash rc does not exist. Again, in that case, create the file. Then you can see these two exports that I have set up. The first export is for path with a local bin. I will explain the relevance of that in a second. However, we have the HPC cache home directory, which is the one that I have been talking about. So once you add this line to your bash rc, you should be effectively set up and ready to not worry about your cache. Besides conda, which we will get to in a second. So we have that, and once you set this bash rc, the important thing is to run source over this bash rc file, because the changes do not come into effect until you either relog in or run the source command. So if you run source and then .bash rc, you will see that now your setup will be configured correctly. So that is setting up cache. This is a very important step. So I will again wait for everyone to make sure that it's configured correctly. And once you have this export in your bash, this export line in your bash rc, and have run source, please let me know, and then we can move on. Awesome. In the meantime, are there any questions? Did everything I say make sense, or is someone lost about something? I would be very happy to re-explain. Okay, yeah.
Do you mind going over
Like in the bash RC, can you pull up the console?
Yeah, bash RC is up there. So the bash RC is the kind of sort of starter template environment that you want to set up and generally configure. So it basically what that does is it just says that your HPC, your cache directory should be within Scratch. By default, it is generally your home, so it is under home / your username and then .cache. I don't have that file or the directory, but normally you would see it over there. And that creates a very significant problem. One very cool trick to kind of figure out where some size woes are coming. So if you run into a situation where you run into the error where it says this quota exceeded, you might want to try and figure out what's causing the problem. And you can do that by running ncdu. It's a very, very simple program. It runs du with ncurses. So you can see that the biggest file right now, the biggest folder right now for me is this contact directory, and that's eating up 4 gigabytes. The apparent size is 6.4. Once this gets over 25, you are going to run into some problems. So we have that. And when it comes to actually using files locally, I generally tend to use symlinks to files in Scratch in order to get that working. Again, I will show you how that can work in a second. So yeah, cool. Let me know once you have that set up. Yeah, absolutely. Yeah. Cool. The line 3 is important. Even if you copy the line before that, that helps because you will have to do that at some point anyways. But yes. If there are any questions, please let me know. I would be happy to run. Right. So in that case, you just want to create the file. You just run the bin and then space and .bash rc. Yeah, hit enter. That will create a new file. See over there. So you just write export the HPC cache. You can copy it from the report. Okay. Hello. Okay. All right. Cool. So we have XDG cache roam set up now with everyone, which is fantastic, and we will reap the benefits of this setup process in a second. The next cool thing that I want to talk about is IPython, which actually I realize is a bit misplaced. So we'll get back to this. We'll get back to this later on. I'll show you exactly why I love this program so much and how to fix this tiny issue. But now we get to the process that I deem most fun. Now we actually set up the interactive job and we actually query the A100. So in order to run a job, there are multiple ways we can do it. The first method is interactively, wherein we have control of the bash shell, and whatever we write, we get an immediate response. So similar to like REPL, but for bash, which is the normal way we run the shell. So instead of the interactive node, we are interacting with the actual job itself. So we have significantly more compute in that case. So you can run the following command: sinteractive-a account. In our case, that's mlp-n. N for the number of nodes. To start with, let's just use 1, and number of tasks, let's use 1 again. I'll explain what all of this means in a second. C is for the number of CPUs per task, or the number of cores that you want to utilize per task. G is the number of GPUs, and T is the war time, which you would put in hours, second format. So let me go ahead and type out the command. So I have sinteractive-a mlp -n, again account. Number of nodes is 1. Number of tasks is 1. Number of CPUs, I'll let that be 2, but I think you can have it anywhere between 1 and 4. And the number of GPUs, I want 1. And then for time, I'm just going to say, I want it to run for 30 minutes, not 330 minutes. Okay, so it says pending job allocation, it's queued, waiting, all of that. But now, once that is done, it says nodes Gilbreth and 001 are ready for job, which is fantastic. So right now, we have access to the NVIDIA A100. So if you run NVIDIA-SMI, you should see the A100 over there and the 40 gigabytes of VRAM that you have just been blessed with. So run this command, check it out, have some fun. It is really very cool. Let me just pull it back up for you all. So this is the filled out command. It is exactly the same. You basically just copy this and you should have NVIDIA SMI or like the A100 running. Yes.
Just for future references, it can be available this way.
Yes, it is publicly available. Cool. Let me see if I can get. Okay.
What was the NVIDIA command you got?
NVIDIA-SMI. This one. Right? And if I run QList, I should see the number of total GPUs that we're using. So we have 39 free. And if everyone here, let's see, how many people are currently following around with me right now? How many computers do we have? 1, 2, 3, 4. I see 4. Okay, cool. So we should. This number should go down by at most about 4. So this is cool. So I can basically see how the thing evolves. We got another one running, and that's the total utilization. But yeah, cool. Go ahead and try to run it, and once you are done, let me know, and then we can move forward.
You're virtual.
Okay. Has everyone been able to run the cluster? Can I please get a show of hands? Does anyone need help? Is everyone good? Good. Y'all are good, I suppose.
Yep.
Yes. Okay. Cool. All right. Now wait another couple of seconds, and we should be good. I'll have the command up in the meantime. All right, cool. Now I'm going to just talk about what each of these components are doing. So the first thing is the account. So if you notice when I ran QList, you can see the list of we can see the list of queues or the list of accounts that we have currently available. So there is debug, standby, and MLP-n. Debug and standby are shared queues, which is run by most of everyone who has access to Gilbreth. But MLP-n is the one that is used specifically for us and is only used by us, which is awesome. So we have this setup. We see the node type over here, which is n. It's just the subset of the cluster. So they have node types all the way from A through, I think n is the latest one, and each of them have their own specific features. So we have this sfeatures command, like this suggests. It talks about just the type of compute that is available. So the n has H100s. We can request at most 4 of them. Over here we see the A100s. We can request at most 4 of them, and so on and so forth for the rest of the nodes within, and so on and so forth for the rest of the nodes within Gilbreth. So there's that. And in the future, you probably will run into such a situation where you have multiple types of chips. So let me see if there is an example over here. A30, V100, A10, all of them are more or less the same, or exactly the same. Okay, so for Scholar, you will run into a case where there are 2 different types of GPUs available. There are 16 gigabyte GPUs available and 32 gigabyte GPUs available. Both are V100s, but they have different amounts of VRAM, and you can configure or specify which to use by using a constraint that is present within these following features, which is cool. NVLink, I think, combines 2 GPUs into one, so you get 80 gigabytes of VRAM and twice the power of the A100, but as a single integrated piece. So maybe that works, but I'm not entirely sure. Maybe Geoffrey will know. Is NVLink enabled for us?
So NVLink is available on a few partitions, and I think coincidentally, yes.
Nice.
On the N partition, you have 4 A100s NVLink, yeah.
Okay. So if you request 2,
yeah, it says it right there. Yeah.
Right. So if you request 2 NVLink GPUs, you will get effectively, that would be our effective maximum, correct? Or not?
No. So Slurm doesn't understand anything about NVLink.
Okay.
That's just text that we labeled it with.
Uh-huh.
So you can request up to, I think in order to use NVLink, you'd have to request all 4 GPUs.
Oh,
and
okay.
have you need to make sure all your GPUs are on the same node, and
Right.
you want exclusive access to all 4 of them, and then you can.
Then you can use the NVLink.
Yeah, and you kind of have to do a little bit of work. Like, out of the box, the GPUs act as discrete GPUs.
Right. I see. Cool. Thank you. Okay. So we have that, and let's with that go back to the actual track, right? So now that we have the ability to set up a job, we need to set up an environment within which we can run this job, because having a A100 does not mean very much if I type Python version over here and I get something that is desperately deprecated in 2.7.5, right? That is not something that I can use practically, and not someone really anyone should be using practically at this time, because it is deprecated. So the approach to configure the environment within this is using modules. So it allows for some degree of flexibility within the system, because different people have different needs with respect to the type of packages that they need. So having or installing every single type of package usually is not even possible, because some might need a specific version of something and someone might need a lower version, and the two versions don't coexist very easily. So module sort of makes that process for us a little bit more straightforward. So if you run, let's keep this in the background just for my reference. So I have module list, purge, and AV that I want to talk about. Okay, cool. So module list will show all of the modules that are currently loaded. We have Intel, CUDA, RCAC, IMPI, and Xalt. The one that is most relevant to us at this time is CUDA and CUDNN, and finally Anaconda. So I am going to load these three. So module load CUDA, CUDNN, and Anaconda. Now once I load this, I can run module list again, and it shows me the updated, or like it shows me the fact that I have CUDA and CUDNN. One very key thing to note is the fact that it is using an older version of CUDA and CUDNN by default. This works by default for TensorFlow. However, PyTorch requires the latest version. I tried running this, I guess, an hour ago, and realized that I was running into a segmentation fault every time my model ran any type of inference. That was because the CUDA version was outdated, and the process for updating it is rather simple. All you really need to do is run module AV and then the package that you are trying to check out, and it will show you all of the available versions. I'm going to pick out the one that is the latest, and then just run module load and then that version. So it shows me that it has updated CUDA, because CUDA and CUDNN are interlinked. It is now from 11.2 to 12.1 and 11.2 to 12.1, but for CUDNN. So this way I ensure the fact that my model is going to be trained properly. If you are running TensorFlow, there is a resource that specifies exactly what version of CUDA and CUDNN you need to run. So just pick and choose accordingly based on the version of TensorFlow and the version of Python that you are running, and you will not run into any issues. But if you do, please let me know, and maybe we can try and figure that out together. Cool. So we have that, and then finally you can get an extended description of that using of a specific version using module spider. Generally this is not super important, but it is definitely helpful to understand what something is doing if it is not entirely clear on the surface. But usually just looking it up online is a kind of a straightforward way to go about it. Cool. So we have that, and now that we have Anaconda, we can create a Python environment with the updated set of libraries that works correctly. So the command for creating a package via CUDA is fairly straightforward. We run conda is fairly straightforward. We run conda create -n, give it a name. I'm going to give it HPC-workshop for now. I'm going to give it a path. This is very important, and actually something I realized I did not include in this dependency. So it by default will create it under this .conda path, which is going to eat up your storage, right? So that's something you do not want. So you can redirect this to save to your scratch space by having this prefix tag, and then just redirecting the path to your scratch storage. So if I do that, and then just do conda and leave it at HPC workshop, it configures the workshop, and if I hit yes, it will create it. So I guess it already exists, so let me just name it HPC workshop 2, and no, that's not right. Okay, let me just rename it to something completely different. I'm just going to call it HPC. I know for a fact I have not named anything HPC so far. So, okay, no, I guess this is just exactly how it looks. Maybe yours might look a little bit different. It generally takes a little bit longer to resolve packages, but I guess it's cached or something because it's not giving me that issue. But anyways, once you hit yes, it should say to activate this environment, use conda activate HPC. which is exactly what I am going to do. And once I do that, it does not work. Okay, let me just explicitly specify the path because I know for a fact that that will work. Not hugging face, Conda, HPC, run. There we go. Cool, fantastic. So here I am now inside this Conda environment. And if I run a Python version again, if you recall from last time, we had some 2.7.5, but in this case we have 3.8.5. So this is a more modern version. If you want to explicitly specify that, even explicitly specify the version as well, you can do so. So I'm actually going to do that. Let me create a new environment here with the Python version as 3.11 and call this HPC2 and just do that again. Yeah, this is what I was actually looking for. Cool. So that is what I was missing. I forgot to specify the Python version and safety error. Okay, we don't worry about this. It's a warning. Not an error. Cool. So we have this setup is configuring a Conda for us now. So once that is done, you should be able to activate it and run Python version, and it should show you the Python version is now 3.11, which is what we need for, again, I need to specify the path, Scratch, Gilbreth, username, Conda, HPC2, and then if I run Python version, we'll see 3.11.8, which is exactly what we wanted. So fantastic. We'll pause here. Please configure this on your own machines, and if you run into issues, please let me know. If y'all have already been following along through the README, please give me a thumbs up so I can know speed up a little bit. But yeah, I'll wait for a couple of minutes and then come around. If anyone needs help, please let me know. Okay, so I'm going to move ahead and maybe a little bit quicker so that we don't keep the other people waiting. So we have the HPC2 environment set up. The next thing that we are going to do is just use pip in order to install everything. But one cool trick that I would like to demonstrate before that is UV. So if I go over here, there is this link to UV, which is a very fast package manager that is built on Rust. So the installation script is basically just the first line within getting started. You copy and paste this line, and once you do so, it installs it for you. You should run UV, and you should see these set of commands. Now you can just treat pip exactly how you would normally install packages, but just prepend UV to it. So if I go to the repository with the set of code that I had from earlier, if you clone the repository within your file system, you should have a couple of things. You should have the models and data.dvc files, but not the directories. You should not have a mlruns directory, but you should have a scripts directory, requirements.txt file, and a source file. So in order to install the requirements, all you need to do is run uv pip install and then tag r and requirements. Once you hit enter, it will automatically resolve all of it for you, and this is going to happen in rapid time. The installation process is basically instantaneous. The only time drain you have is the time that is spent downloading the packages itself, which thanks to Gilbreth's networking speed, we don't have to really worry about. So this will take maybe 20 times the time it takes with regular pip. That is something to definitely check out even outside of a HPC environment. Just always use UV. It's great. So while that installs, it did already install. Fantastic. We now can enter, or let me actually also install IPython, or at least make sure that it's installed. It isn't. So now that I installed IPython, I can kind of log into this new REPL environment, and I can import something like Torch, which is something that I have set up, and we can see that it imports correctly. So that's basically our configuration process done, and now we can run the actual script itself. But this time we are going to run it non-interactively. So earlier, what we were doing was we were just creating this interactive job and actively playing around with bash during that process. Now, this is not an ideal way of going about things, simply because when you are trying to run or like launch a training run that is going to work for a period of days, then you do not want to have an interactive shell that is at control of this process. So the way you go about this is by creating a non-interactive job and running your program in the non-interactive job, and then once you do that, you can effectively just log out, shut down your computer, go home, go to bed, and then in the morning come back and look at the results of your training. So in order to do that, we have to specify the same set of things that we mentioned within our sinteractive command, but in this case we do it within a file and pass sbatch to that file in order to trigger the job. So I'm going to quit this IPython environment and I am going to run a prepare function. So on your, actually maybe I'll just skip this because my stuff is already prepared, but in the event that you are cloning this repository, you will not see the data and you will not see the models directly. In order to prepare that, you want to run scripts slash prepare.sh. Once you do that, it will download the file for you, and once you download the file, it will unzip everything and basically just configure the entire data. Now importantly, again, if I run lsla, I see that I have the models directory that's redirecting to HPC workshop/models, and data that was until it started unpacking, redirecting everything to the similar models directly within Scratch. So let me actually rmrf this data and link up the actual data that's present within Scratch. So lsla, right, cool. So if I go to the data, I see that my data does not exist. Okay, fantastic. Let me just run the command anyway then. Okay, scripts prepare.sh, and once I run this, it will unzip it exactly like I mentioned, but this time I will allow it to run completely So it's downloading data from the animal 10 data set. There are 10 animals, and there's a model that is attempting to classify these 10 models as accurately as possible. The task formulation is not super important. Whatever you are working on, it will remain relevant to that. Just ensure that you are redirecting to a scratch folder, and you should be okay. So once you have this set up, the last thing that we need to look at is under scripts and SPatch. Now here is where we specify the constraints that we required from earlier and include some things like my personal token, which I have publicly shared. Amazing. Cool. $token, very private. Do not share. Okay. Reminder for next time, I guess. So we have this script. Within the script, there are a couple of things that are interesting. The first thing is the commit with SPatch. We specify a couple of flags. So we have account, in this case it's MLP-N, gress, which is the resources. We are requesting 1 GPU, and time is 2 hours. The remaining are default. So I think the default is going to be 1 task, 1 node, and then 4 CPUs. But if you want to explicitly specify or change that, you can also do so. Once we have that, the next thing I'm doing is loading CUDA and CUDNN, and specifically the updated versions, in order to ensure that everything looks fine. And then activating the repository. Once I do that, I log into the directory and then run training with my token. So in order to actually go about this process, I will probably change this token later on, but we have this and the directory. This is still CNN workshop, and the conda file is different, so I'm going to change that to this. And now once this entire process is set up, all I need to do is run SPatch, scripts, and then SPatch and hit enter, and it says it's submitted batch job 5221 AAA. And now this job is actually running the training code. It uses the environment that we set up under the time constraints that we established within the job, which is fantastic, and more or less concludes the overall deployment part of this workshop. But one very cool thing that I want to talk to you about before we close for today is the ability to actually hook on to this job. So we see that this batch job is running now, and if I, or hopefully is running, let me run SQU and my username in order to see the jobs. So I see that it is in fact running, and it has been running for the past 40 seconds. 1 node, 1 CPU, I was wrong, it's not 4. And the spatch.sh is the file. So fantastic. Now we have this. However, we may want to actually run into this or get into this environment to figure out what's happening. And we can do that using srun, where we specify the job ID and then paste this job ID, then specify a process. In this case, we want to run bash. So I'm going to just specify bin/bash and then I for interactive. And now, once I do that, I am in this bash shell. And now when I run NVIDIA SMI, if my process has currently started, and it has in fact started, we see that it is using 7.3 gigabytes of VRAM. This is the actual training process that is running under the hood. And if I go back to the repository, I can see under the experiments tab over here a new experiment that has just begun, and it logs the process of training. So obviously there is nothing over here at the moment because it will take some time for the epochs to roll in, but once we do, we will see it, and we will have a model at the end of this process that we can observe. So let me quickly redirect to this repository that does have successfully completed experiments. It's the exact same code. There is nothing that is changed besides the README file itself. I can see there are two comparisons that I'm making. One is an ImageNet pre-trained model, and one is just randomized weights. And I can see that the performance of the ImageNet model is significantly better. So just a very simple experiment to lay down the proof of concept with regards to this idea. So that I think is all that I have to share. Thank you so much for listening. Thank you so much for coming. And if there are any questions, I would be very happy to take it offline once we let whichever workshop runs next to get started. Thank you so much.